Hello, up fifth. I'm going to review the photosynthesis prep, the one I referred to in your reports. I'd like you to get your paper out, have it with you, and in corrections as you go, because a lot of you didn't do well in this. So if you've got a horrible U there, you know you've got to put a lot of detail in. Even people who got Bs, you know, I want you to put information in. I've written out the word equation for photosynthesis and balanced it. So it's sort of half word, half symbol actually. CO2 and water with light energy makes glucose and oxygen. Plant loves photosynthesis because it makes food. Glucose, oxygen is just a byproduct, okay, which we quite like. So when it comes to what affects the rate of photosynthesis, you've got to say CO2 does, water does, light does. Okay, all the things you put in are going to affect it. And because it's an enzyme-controlled reaction, certainly temperature is going to increase it. Okay, so applying the same theory of enzymes. So as light intensity increases, the rate of photosynthesis increases, however it plateaus. What we say is that light intensity at this point is the limiting factor. The reason why that isn't higher is because there's not enough high light intensity. See, being here on the x-axis means lower. So whatever is on the x-axis tends to be the limiting factor at those points. No, it is. I shouldn't say tends. So at plateauing, the reason why this isn't higher, no matter how much the higher light intensity goes, it's not getting any higher because perhaps the temperature is not right or the CO2 is not right. They are the limiting factors at that point. So look for that, light intensity there. Over here, look, CO2 on the x-axis now, CO2 there, that's the limiting factor. And you've got the other two limiting factors there, temperature, light intensity. Now you might ask, where's water? Water doesn't tend to be a limiting factor because cells are so full of water. It's rarely the one that changes. Of course, if there's a complete dehydrated plant, you're in trouble. But, you know, in terms of a greenhouse, it's these three factors which the farmer cares about. And you can see the temperature there, slightly different. But it can show that same plateauing. Okay, so you can have it like that, but on the whole, if you just looked at temperature, you say temperature is a limiting factor there because it's too low, and there the temperature is a limiting factor because it's too high, limiting the rate of photosynthesis. Hope that's okay. So when it comes to this experiment, well, they're asking what patterns can you find? 5 marks. Certainly increasing light intensity increases the rate of photosynthesis, however it plateaus. That's a pattern you can see. It's basically describe. Okay. And oh look, from this you can see, look, it goes from 0.03% CO2 to 4%. Oh look, that CO2 increases the rate of photosynthesis. What about temperature? It goes from 15 to 25. There's a little bit of a increase there, but oh, that looks like a good one. 15 to 25 increase in temperature increases the rate of photosynthesis. However, look, this is the 5th mark, which is trickier. Increase in CO2 increases it more than temperature. So from when it goes from 0.03% CO2 to 4%, so even if you look at the same temperature, like 15, there's a big jump up there. There's not such a big jump up when you increase the temperature. So from there to there. Okay? How useful is this? Great. I mean, this data is great because the farmer goes, hey, look, I should definitely put 4% CO2 and 25 degrees Celsius. I should increase my CO2 concentration and my temperature because it increases the rate of photosynthesis. Oh, and I should put a high light intensity. So this is kind of like the optimum there. Okay, so that light intensity, whatever it is, that CO2 and that temperature. No point doing it any higher because it's not increasing the rate of photosynthesis anymore. You might even say that it should be further back there. No, actually I reckon I was all right there. So when it comes to this experiment, you've done it, so living it is going to help it be more memorable. You just want to change the light intensity because he is investigating light intensity. See, I've highlighted that. He wants to make sure that things like CO2 and temperature are the same. He only wants the light intensity to change. So adding a test tube of water in front of it could actually be quite good because you can change the distance there, but this isn't going to warm up by being close to the bulb. So we say what the students do to make sure the heat from the lamp didn't affect the photosynthesis, put a test tube and water between it. Someone wrote that it will cause reflection. No, that's you want the light just to go straight through. This is about absorbing the heat. Here's the experiment data, number of bubbles per minute. And I hope you recognise that, you know, that lots of bubbles, that means a high rate of photosynthesis. And look, it's a small distance. That's exactly how you did your experiment. At distance between 15 and 50, light was the limiting factor. Okay, so actually, if you can transfer this into a graph, it would certainly be like that. Okay, so the higher light intensity, it increases the rate of photosynthesis, and then it plateaus. So as the light intensity increases, so like there, so from being far away to being close, what happens to the rate of photosynthesis? It increases. Okay, you get more bubbles. Okay, what evidence is there that light was the limiting factor? Increasing the light intensity by bringing it closer increased the rate. Okay, so light intensity limiting factor at this point. One factor that could have limited the rate of photosynthesis when the distance was between 10 and 15. So when it was really high, so like that sense, what was it? Of course, it could be temperature or CO2. Okay, perhaps there's not enough. Okay, remember in this experiment you have controlled it. Give one factor that could have limited the. Oh, sorry, I've done that one. So hot summer's day, you're going to have nice temperature, high light intensity. Probably the only limiting factor is going to be CO2. So you can see, like, if it's a closed greenhouse, CO2 can't get in. So that will probably be a bit too low. But it'll be warm and sunny from a hot day. Starch. Plants make glucose during photosynthesis. Some of the glucose is changed into insoluble starch. It's stored for later use. The student investigated the effect of temperature. Okay, so I've highlighted that. That is different to the other one. That was light intensity. Suddenly you've got to readjust it. So you've got to have different control variables. State two variables the student needs to control. If he's changing temperature, he wants to keep CO2 and light intensity the same. What two measurements do the student have to calculate the rate? So basically, what is the dependent variable? It's the number of bubbles produced per minute. What two things that he has to measure is definitely number of bubbles and then the time. Okay, so getting a habit of that. They're all part of the dependent variable. That's why it was good having two of you doing the experiment. So here's this familiar graph now. Name the factor that limits the rate of photosynthesis between A and B. A and B, temperature. Seen that before. Suggest what factor, CO2, oxygen or water, might limit between C and D. Now you don't have light intensity in that list, so that's the reason why you extract it and go, right, boom, must be CO2. Okay, most likely. Word equation photosynthesis, easy peasy. 2 marks, couldn't get easier. And here's that setup again. Quite nice actually. So rather than just having the bubbles counting, you've got the bubbles coming through here. You've got a thermometer and a water bath. Great. Some student invested. There you go. That's that temperature again. Water bath. I'm immediately thinking this could be thermostatically controlled, so you can put the dial to like 37 degrees Celsius. So that's the next question. Why do the students use the water bath? To control or to change the temperature to the desired value. You know, if I want it at 37, I could change it to 37. So here we go. This is that